Example 3. Use the graph to find the domain and range of the function, intercepts if any, horizontal asymptotes if any, vertical asymptotes if any, oblique asymptotes if any. All right, so we have 3 different graphs that we're going to look at and try to read off this information from each graph. Okay, so let's take a look at the graph in. All right, here it is. Okay, so the first thing that we're asked to find is the domain and range of the function. Okay, so I'm just going to jot all this information out to the side. Okay, so let's start with domain. Okay, so you don't have a formula to rely on, and that's okay. We're just going to get everything we need from the graph. Okay, so basically you definitely see asymptotes. Okay, the blue pieces are the actual curve, and then the red dotted lines, those are the asymptotes. So I do see a horizontal asymptote and I do see a vertical asymptote. Okay, those can be really helpful actually in determining both the domain and the range. Okay, so if we're looking for domain, remember that's all the x values that this graph covers. Okay, it's all the acceptable x values, the x values that you plug into the function and you actually get an output. Okay, which is kind of hard here because you don't have a formula to go on. Okay, but if you look at the vertical asymptote here, okay, so this is the vertical asymptote, the one that's up and down. Okay, you see that it goes through x equals -1. Okay, that's where this vertical asymptote is located. Okay, what it's telling us, okay, now keep in mind the graph goes this way forever. Okay, and it goes up this way forever, it goes up this way forever, and it goes this way forever. Okay, what it's telling us, this asymptote is telling us that at x equals -1, okay, there's no output. Okay, the graph, this piece, if you see where my cursor is, this piece is getting closer and closer to that vertical line, but never touching or crossing it. Same thing, this right piece is getting closer and closer to the yellow line, but never crossing or touching it. So basically what's happening here is this vertical line at x equals -1 tells us that this is an x value that has no output. Okay, so the domain here is going to be all real numbers except x equals -1. Okay, so you can write it, in words, or you can write it in interval notation like this. Okay, but with these rational functions and you're looking at their graphs, the asymptotes can be really, really helpful in trying to determine the domain and the range. Okay, so now we're going to do range. Okay, we know range is all the y values that this graph covers. Okay, so now I'm going to take a look at the horizontal asymptote. The horizontal asymptote is actually the x-axis here. Okay, so again, if you're thinking about, the asymptotes and how the graph is behaving around the asymptote, if we look at this leftmost piece, you travel along, you can watch where my cursor is. The graph gets closer and closer to the x-axis, but does not touch or cross it. It stays above the x-axis. And then if you look at the rightmost piece in this direction, the graph gets closer and closer to the x-axis, but never touches or crosses it here. Okay, so this horizontal asymptote here, okay, what's happening here is these two pieces, the blue pieces, they're covering all the positive y values. Okay, they cover all the positive y values. They get closer and closer to the x-axis, but never touch or cross. Remember, the y-axis has the equation y equals 0. Every point on the x-axis has a y value of 0. Okay, so basically, the y value here, there's no point on your curve that has a y value of 0. Okay, so 0 is not in the range. Okay, so also something to notice, the graph doesn't exist down here. Okay, below the x-axis, okay, below x-axis, no graph. Okay, so that means no point on the blue graph, okay, has a negative y value. Okay, so the y values that you get here, okay, your y values are going to be all positive y values are in the range. Okay, we don't get any negative y values. We don't get 0 as a y value. Okay, so the range here is going to be from 0 to infinity. Okay, your y values have to be strictly positive. Okay. All right, so that was domain and range. Okay, intercepts. That's the next thing we need to write down. Okay, and that means both x-intercepts and y-intercepts. Okay, if we do a quick scan of the x-axis, okay, you can see that the blue graph never intersects or crosses the x-axis. So as a result, there are no x-intercepts. So no x-intercepts. And then we can do the same thing by looking at the y-axis. Okay, if we scan the y-axis, okay, boom, our curve does intersect the y-axis once right here. Okay, this is the point 0, 1. Okay, so the y-intercept is right here at the point 0, 1. Okay, all right, horizontal asymptotes. Okay, let's do that. Okay, so we know, we've already talked about this, the horizontal asymptote here is in yellow. Okay, and it is the x-axis. Okay, when you write down your asymptotes, you're going to be required to write them as equations. Okay, so the x-axis has the equation y equals 0. Okay, we've discussed that. The reason for that is that any point that you select on the x-axis has a y value of 0. Okay, I think the next thing we need to find is the vertical asymptote. Okay, we said there is one. Okay, let's see here. The vertical asymptote is the red dotted line. Okay, so let me change it here. Here, this is your vertical asymptote right here. Okay, it's that blue line. Okay, it is a vertical line. Remember when we learned about lines, that vertical lines have the form x equals. Okay, we said earlier that this blue vertical line goes through x equals -1 right here. It goes through this point. Okay, so the equation of this vertical asymptote is going to be x equals -1. Any point that you pick on this vertical line is going to have an x value of -1. Okay, I'm going to highlight that in blue to kind of match the color coding here. And then the last thing we need to look for are oblique asymptotes, if any. Okay, if there were an oblique asymptote, I told you you can think of that as a or a slant asymptote. It would be like an asymptote, so it would be a red dotted line here. It would have the form, it would look like a y equals mx plus b. It would be a line with slope. Okay, so not a vertical line, not a horizontal line. Okay, and you don't see one of those here. Okay, so there's no oblique asymptote here. So I'm just going to write oblique asymptote, none. All right, so these are all the characteristics for this particular graph, and we're going to jump into the next one.